let's talk about the correlation coefficient. Correlation is a mutual relationship or a connectedness between two or more things. Now, the correlation coefficient is going to tell us about the relationship between our two variables. The magnitude of the correlation coefficient tells us about the strength of the relationship. And the sign, whether it's positive or negative, is going to tell us about the direction. And we'll see what that means in a moment. Now, importantly, the correlation coefficient is always a number between -1 and 1, including -1 and 1. Now, you might have seen an inequality that looks like this before when you've done sequences in series and you were looking at the ratio, the R value, that would allow you to have a convergent rather than a divergent series. Now, infinite series. Now, here, that does not mean that at all. It is just a coincidence that those things look so similar. The correlation coefficient has nothing to do with that common ratio for a geometric sequence. Right, so the correlation coefficient tells us, as we said, about the relationship between the data, how it moves together, and how strong that relationship is. Now, if I've got a scatter plot that looks like this, all of these points fall on exactly the same line. And that's what a correlation coefficient of 1 looks like. And we would describe that as being a perfect positive correlation. An example would be the number of units that you sell that is plotted against your profit. Now, because you set the markup for every unit that you sell, every unit brings you the same profit, and there's going to be a perfect relationship. If you know how many units you've sold, you can predict exactly what your profit is going to be. Now, if those points are a little bit further away from the line, but they're close and it's pretty certain that we've got a linear trend there, that's going to be a correlation coefficient of around about 0.9. And that represents a strong positive correlation. So it's not perfect, but it is strong. And an example might be the number of customers that you have and the profit that you turn. Now, each and every customer is not going to spend the same amount of money. So knowing how many customers you have isn't necessarily enough information to know exactly how much profit you made, but in general, it's definitely true that the more customers you have, the more your profit is going to be, and that's the sort of thing that might have a strong positive correlation. Now, if we stray a little bit further from our least squares regression line, then we'll have a correlation coefficient of maybe about 0.5, and that's going to be a moderate positive correlation. So it's not strong, but it's fair. It's there, you know. And an example might be height and weight. Now, in general, yes, taller people weigh more than shorter people, but sometimes you have tall people who are very, very skinny, or you have shorter people who are a little bit more muscular and stocky, and then this relationship isn't necessarily as linear, right? Then, if we have points that are even further from that line, that might then be a correlation coefficient of about 0.2, and that would be a weak positive correlation. Now, a weak positive correlation is starting to say that actually these things aren't all that related. There's a bit of a trend, so, you know, as one thing increases, the other thing probably increases, but it's not certain, okay? And an example could be the water usage and the number of household members. Now, often you have a household with one person and they've got a pool and a garden and they use lots and lots of water, and then maybe you have a household of 6 people and they don't have a pool and they don't have a garden and they only use water for cooking and cleaning. And so there's a lot of variability between how much water people use, and it doesn't depend so much on how many people are in the household. But yes, in general, you know, as we go up with the number of people in the household, we will have, you know, a trend of increased water usage. And then if our scatter plot looks like this, then there's no trend there whatsoever. And that's going to be a correlation coefficient of 0, and that means there's absolutely no relationship. There's no hope of using the x value in order to predict what the y value is going to be. If you have a certain x value, the y value could be absolutely anything. There's no relationship. And something like that might be how many fish you catch on a fishing trip and how many cigarettes you smoked that morning. Now, for that, like smoking doesn't make you better or worse at fishing, it's just not going to have any sorts of relationship. Right, so then as soon as our line of best fit starts sloping negatively, that means that we now have what we call a negative correlation. And that means that as one variable increases, the other one actually decreases. Now, the magnitude of the correlation coefficient is still going to tell us the same thing, how close those points are to the line of best fit. Right, so a weak negative correlation is what you're seeing there. And then if the lines get closer to the points or the points get closer to the line, that's going to be a moderate negative correlation. And maybe something that could look like this is the average time that you spend exercising and the days that you are absent from work. So people who exercise more are probably likely to be more healthy, but it's not necessarily the case. But in general, the healthier you are, the less you're going to be sick, and so you'll be absent from work a little bit less. So that might be a negative relationship, whereas one thing increases, the other thing decreases. But it's not to say that that's like the main determinant, because people miss work because they're lazy or because they just need a break, and that doesn't have a lot to do with actually, the time that you need to exercise. Okay, and then as we get closer to that line of best fit, that's going to be a strong negative correlation, and then this will be a perfect negative correlation where each and every one of those points are going to fall on the line of best fit. Okay, so as a general trend, when the correlation coefficient is positive, that means our line of best fit is going to have a positive gradient, which means as one variable increases, the other variable increases as well. And when we have a negative correlation coefficient, our line of best fit is going to have a negative gradient, which means that as the one variable increases, the other one will decrease. So, what on earth is the use of this correlation coefficient? Why do we care? Now, the reason we calculate a correlation coefficient is because it tells us how much we can actually trust the predictions that we make from the line of best fit. Now here I've got two scatter plots, and mathematically when we go calculate the line of best fit, we actually get identical lines of best fit from these two scatter plots. However, for the first scatter plot, we have a correlation coefficient of 0.9, and for the second one, we have a correlation coefficient of 0.2. Now, what that means, as you can see, is that for the first one, the points are on average closer to the line of best fit. And what that means is that the predictions that you make using that line of best fit is more likely to be accurate or reliable, and that is because there's far less variability between the possible values of y for a given value of x. Okay.